today I'm showing you electron configuration. So, you're going to go by this. I have it written down right here. This is how we're going to do it. Don't know how much further we'll be able to go. This should be... We shouldn't have to go any further than that. So, these are your energy, like your orbital shells. So, this is how many each of them can hold. The S block can hold 2. The P block can hold 6. The D block can hold 10. And the F block can hold 14. So, and then as you're going down this is how you're going to go. You do the S block, the 1S, and then you go 2S, and then you go 2P, and then 3S, and then you go 3P to 4S, and then you go 3D, 4P, and then you go 4D and 4F. So, no, I did that wrong. No, I didn't. So you do it like that. So your first one on this example is here, this right here. So beryllium with a positive charge of 2 is going to be helium. So that will be the noble gas configuration, will be helium. So you put this, whatever noble gas you're wanting to, the charge is making it go to, and you're going to just write the configuration for it. So the atomic number shows the amount of electrons in an atom or an element. So helium has 2 electrons, so that can fit in just one S. So, and then you just add the amount of electrons right here. So that's the electron configuration for helium, which is the noble gas configuration of beryllium. And then you can also write the actual configuration for beryllium. Since beryllium has 4, it's just going to be 1s2. And then you move down to this one next, and it's 2s2. Because you can only have a max amount of 2 electrons in the S block. So that is the configuration for the noble gas configuration for beryllium and the electron configuration for beryllium. Moving on. Okay, moving on, we can do the next one is nitrogen with a charge of -3. So that's going to go up 3, which the noble gas configuration of nitrogen, the -3, would be neon. So put it up here, you put it in brackets, and then you do the configuration for neon. You just take neon and you break it down. So it's going to be 1s2, since you can only have a max amount of 2 electrons, and then you're going to have 2s2, because so that's 4 so far, and then you'll have 2p6, And that is how you break down neon, because see, all of the exponents have to add up to be the amount of electrons in the atom, which neon has 10. So 2 plus 2 plus 6 is 10. So that is how you find the noble gas configuration of nitrogen. Nitrogen itself, if you want to break that down, is 1s2 and then 2s2. See, that's 4 so far, and we need 7, so then it's going to be 2p3. 2 and 2 is 4, plus 3 is 7. So that is how you break down the electron configuration and the noble gas configuration for nitrogen negatively charged. So looking at your periodic table, if you go over just one from chlorine, that is another noble gas, which is argon. And then you just break down argon. Argon has 18 electrons. So we have to fill up our orbitals to our orbital like blocks to get 18, so that will be the noble gas configuration of chlorine. So we have to break down argon. So now we have 1s. So now we have 1s2. So we have 2 so far, and then we're going to have 2s2. Now we have 4, and then we go 2p6. So now we have 10. And then we go back to 3s2. 2, 4. So now we have 12. Okay. And I'm going to go under. And now we go to 3p. And 3p can only hold 6. So since we have 12, we only need 4 more. Yeah. No. 6 more. So now we just fill up this last one. And it is this. A very long configuration. So this is that's your configuration of argon. And then if you want to break down chlorine, just chlorine by itself, that would be, chlorine has 17, so it'll be 1s2, 2s2, 2p6, and then 3s2. So far we have 2, 4, 10, 12. We have 12 so far. Then we go 3p. So 2 and 2 is 4. 4 plus 6 is 10. 10 plus 2 is 12. 12 plus 5 is 17. So that is your breakdown of chlorine. Krypton has 18 electrons. So now we just got to, I'm going to do it down here. We just got to break it down. So it's going to be 1s2, 2s2, 2p6, 3s2. Let's count so far. 2, 4, 10, 12. All right, we got 12 so far. And now we go to 3p. It's just going to have 6. So it's going to be another full one. We had 2, 4, 10, 12, 18. There's your breakdown of krypton. And then if you want to break down rubidium by itself, just do it like this. Okay? It has this will be a big one. This is going to be a really long configuration, so I'm going to write it up and leave it right there. Just take this off. So rubidium has 37 electrons. Okay, so it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Let's count so far. 2, 4, 10, 12, 18, 20. Okay. 4s, and then we go to 3d. Can hold 10. So we're going to put 10. 20. Now we've got 30. And we have to go down to, I know it's not written up here, but now we've got to go to 5s. 2. Now we've got 32. And then we go to no, hold on. 3D as 10. You will actually go 4p, and you'll go 4p6, and then I know it's not on here, but you'll go 5s1, and that will give you 37. So that's how you do that. Thank you for listening to my chemistry lesson.